Okay, so this is going to be a super duper quick refresher on the difference of a relation and a function, and then we're going to talk about a couple different things about functions and ways to test if something is a function. So, a relation is a set of pairs of input and output values. Basically, it's some x's related to some y's. Thus, you get an ordered pair. Dang. So, there are four different ways. You can represent them as an ordered pair. You can put them into a domain and range map. You could put them into a table, or you could express them on a graph. Now, you can see how -3 goes to 4, 3 to -1, 4 to -1, and 4 to 3. If you don't remember how to express things as a domain and range map or as a graph, I would highly recommend YouTubing or Googling it on the internet so we can do that, because we're not going to spend a whole lot of time relearning how to represent relations and functions. Instead, here are the four ways. Inputs are your x's, so domain, x values, input, those all stand for the same thing. You can see those are in red in the ordered pairs below. Dang. Let me get rid of that nastiness here. So domain, underlined in red. Let's give it some red words if I can. Yeah. Is also input or x values. The range, you can see down below, these are the blue. Those are your outputs or your y values, and we call those the range. So, when you make a domain and range map, it's pretty simple. Whoa. You put all of the domains, your inputs and x values in one, one chart. Then you put all your outputs, y's, or ranges in the other, and then you connect the ones that are connected in your ordered pair. So, you can see the domain, -3, 0, 2, 9, 23. What about the range? 14, 7, 0, -18, -99. Normally we put these in order if we're going to put them, list them as a domain and list them as a range. So my range would be -99, let's -99, -18, 0, 7, 14. That's my range. Let's change this back to red so I can get my domain. It looks like it's already in order, so -3, parentheses, -3, 0, 2, 9, 23. So there is my domain and there is my range. And that's it. I mean, you can see you don't have to put them in order. A lot of times people set them up to where they line up as this set as well. I like to put them in order because it'll help us when we see the domain and range of a graph. You can see the domain in this case is -3 to 23, and the range is -99 to 14. That's why I like doing it this way. But as long as you can find what the domain and what the range are, you're in good shape. Now, is it a function? A good way to tell a function, the rule for a function is every input has exactly one output. Meaning every x has exactly one y. But that doesn't mean that multiple x values that doesn't mean that multiple x values can't be represented, there we go, or paired with the same y. Meaning, in this case, this is a function because you can see the domain of -3 only goes to -2. The 0 only goes to 7. The 4 only goes to 1. Each domain coordinate must correspond to one range coordinate. So you can put it in a domain and range map and draw these lines to make sure that each one over here is only going to 1 over here. Or you could look at the ordered pairs here. Because we have two, there we go. Because we have two domains of 4, that means the 4 has an output of -1 and an output of 1. This cannot be a function because that is not possible. So how would that look like in a domain and range map? Let's do that like super duper quick. Domain, range. So you can see in our domain we have 1, 8, 6, and 4. In our range we have -1, 6, -1 again, and 1. So -1, 6, and 1. So you can see we've got 4, -1. We've got 8, 6. We've got 1, -1. And this is allowed to happen. So far, this is still a function. Two different x values can go to the same y value, but one x value can't go to two different y values. So far, we're still good. 6 to 6, still good. These two values can both go to 6 as long as one is not going to two different ones. Oh, and then here we get into a problem. 4 also goes to 1. So this is the problem. 4 can't go to -1 and 1 and this be a function. Now 6 can be represented by 8 and 6, and -1 can be represented by 1 and 4, but the fact that 4 goes to two different values, not a function. So hopefully that's a refresher for you. The other thing you can do to test if something's a function is the vertical line test. If you draw a vertical line, so a straight up and down line, if it crosses your graph at more than one point, so not your x-axis, but the actual graph, if it crosses it at more than one point, then it is not a function. So I'm just going to get a little red vertical line here. Let's get one that's maybe not so ridiculous looking. Thin like that. So if I draw a red vertical line through this circle, you can see here that no matter what, you're only touching one point on this graph, so that is a function. Here, you're touching the graph there and the graph there, so no function. Yes function. And let's take a look at this one. Red vertical line. Good grief, Charlie Brown. You can see here, no matter where I draw my vertical line, it doesn't cross more than once. Crosses once, crosses once, crosses once, crosses once. Yes, that is a function. I'm just going to put a y. But you can see here, it crosses there and there. No function. So lastly, function notation. You'll see y equals 3x plus 2 and f of x equals 3x plus 2 are largely the same thing. We kind of went over this like on the first day of school. Your independent variable is x, and it represents the input, no different than what we've done so far. X represents input. The dependent variable is f of x and represents the output. So if I put some input x into an expression, it will spit out an answer, and that answer is f of x. So you can see, how can we evaluate a function? Well, if I have the function f of x equals -2x plus 5, I'll rewrite that. And I want to evaluate for f of 1, f of 2, and f of 3, all I'm going to do is take 1 and plug in for x, 2 in for x, 3 in for x. So, -2 times 1 is -2. -2 plus 5 is 3. -2 times 2 is -4. -4 plus 5 is 1. -3 times 2 is -6. -6 plus 5 is -1. You can see this is the function. Fantastic. Fantastic. This function, when you're evaluating for 1, is 3. And that's how you use and evaluate functions that are in function notation. What I also want you to do is start trying to think back about how to write and evaluate a function, how to write one specifically. We're not going to spend a whole lot of time going over that. We'll ILP it if we need to. So think about this. Tickets to a concert are $35 each, plus a handling fee of $2.50. The total count is a function of the number of tickets bought. What function rule models the cost of the tickets and evaluate for 4 tickets? So the cost is dependent on the number of tickets. So that's the only thing we don't know at this point in time. So our X is going to be number of ticket. They use T. You could use T or X. That's going to be our variable. And so C of T is the cost depending on how many tickets we sell. Cost as a function of tickets. T being tickets. That is going to equal 35 times the number of tickets we sell plus 250 because of the handling fee. So there's our function. CT equals 35T plus 250. Then we plug in 4 for X because we're evaluating C of 4, and we'll get $142.50. If you need some more help with that, YouTube or Google how to write a function, and there's tons of tutorials out there. Do some self-exploration. Goodbye.